Hello everyone, I welcome you to my channel, and today's chapter will be application of integrals. And first we'll discuss about the simple theory, and then we'll go for the applications. And if you just talk about the NCERT and this concept, and as well as these questions what is given are all mostly the questions are very simple. And I think the moment we'll explain it, and just you'll definitely understand that. And application also not very difficult except some questions. And student definitely like this particular topic, and it's very scoring topic, and I hope you'll like it. Okay, just first we'll discuss about the simple theory that is needed for this particular chapter. Okay, this is theory 1. This theory that we're just going to find area bounded by y is equal to fx, okay, and x-axis, and ordinates x is equal to a and x is equal to b. So what you need to do is say that curve is this, y is equal to fx, and ordinate is x is equal to a, x is equal to b, and the x-axis is this. So what we need to do is we need to find out this area. So for that, what we are going to do is we'll first draw one ordinate, okay, here, and we'll just try to draw another ordinate very near to this, and so just try to make a very small strip, okay, small strip, and let's take y as the height of this strip, and this breadth is say dx. So with this we are just getting an elementary area under this particular curve, and let us assume that this elementary area is given by dA. Now how to calculate the area of dA? dA is y into dx. So can you do one thing, that this area that is bounded by this curve and the two ordinates and x-axis can be considered as that it's a combination of, okay, it's combination of many strips, okay, many small strips. And what I'm going to do is we'll just find the area of one such elementary strips, and we'll just sum up from x is equal to a to x is equal to b, right? So this can be done with the help of the definite integral. So in case you just want to get the area, say it's bounded by this curve and two ordinate and x-axis, and if we consider area as a, so we can just integrate this one from x is equal to a to x is equal to b, okay, and this elementary area is given by dA. Now this dA, okay, the value of dA we can just replace with the help of y dx. So you can just replace the value of a is equal to y dx. This is x is equal to a, x is equal to b. So this is the area formula, right? This is the area formula bounded by this curve and between these two ordinate and x-axis, that is in the first quadrant. So we'll just move to the next theory. Okay, and instead of taking y is equal to fx, okay, instead of taking y is equal to fx, if the function is given x is equal to gy, so assume that this is x is equal to gy function, and these are the two lines, that is y is equal to c, y is equal to d, and the area which is going to calculate the area bounded by this curve, and these two lines y is equal to c, y is equal to d, fine, and y-axis. That means we are going to get this area. Okay, so how to calculate this area? The concept will be exactly same like before. We are going to consider one small strip. Okay, we are going to consider one small strip. So let's take another color. We just take one small strip. So this is a small strip, and let us assume the length of this strip is x, and width of this particular strip is dy, right? Because it is along y-axis, dy. So this elementary area in this regard for this particular theory, so elementary area, that is dA, elementary area, it's can be considered as x into dy. And in if A is the area of the whole shaded portions, then we can integrate this one from y is equal to c to d, that is c to d, okay, and dA stands for the elementary area. So here also this area, that is shaded portions, can be considered as that the combination is the combination of the many such small strips, okay, starting from y equal to c to y is equal to d. So we can just replace dA is x, dy. So this is the formula for calculation of area, okay. If the function is given x is equal to zy, and we need to calculate the area from this line y equal to c to y d and along with respect to y-axis. Now based on this is theory 1 and 2, okay. This is both the theories, so are very simple, and just need to discuss few more points related to this. That what happens in case, right, for the other, if I just go back to this, okay, and let me discuss the first one, okay, the first theory. Right here you have seen that here the y is equal to fx between a to b, we have taken this one is yx, that is y equal to fx, we have taken is positive. In case, right, we'll just discuss with the help of this particular concept, right. In case from a to b, this fx is negative. Say fx, as you have seen that from a to b here fx is negative. So if fx is negative, and while calculating this area, that means this particular area, you will find the area will definitely be negative, right? So if we calculate this, that is a to b, that we can use the same formula, a to b, that is y dx. Now as we have seen that from a to b, right, a to b, this y, that means fx will be negative. So this will come, this particular a to b y dx, this calculation will comes to be negative, obviously, this value, right. So when it will come, when the value of this one will be negative, then while considering the area, because for area, what I am going to do is, we'll calculate the absolute value of this particular integral, that is a to b y dx, since it will be negative if fx lies below x-axis. So we need to consider only the absolute value, that means only the positive value we need to consider. So you can just discuss the similar concept with the help of this theory, that is say this, we need to calculate the area of these portions. This is this portion, right, and this portion, these two portions area you need to calculate. That means this two area, this portions is bounded by this curve, right, and between these two ordinates, x is equal to a, x is equal to b, and this axis, that is x-axis, right. And as you can see, right, from this point to this point, right, here if we talk about a1, right, since a1 is lying below the x-axis, here a1 will be negative, right, here a1 will be negative, and since this portion is above x-axis, a2 will be positive. So while calculating the area of this shaded portions, which is bounded by the two ordinates and x-axis and this curve. So what you have to do is, if A is the area of this, the combination of these two shaded portions, right? So what you need to do is, since area, this A1 comes to be negative here, according to this theory, right? So we'll have to take the absolute value A1, that is mod A1, then plus it will be positive, so we need to calculate like this. That is A is equal to mod A1 plus A2. Okay. So with the help of this, so we'll just ignore the minus sign. Okay. Let's move to exercise 8.1. So as I already said that the questions are mostly the questions are very simple and interesting. Okay. The first question is 2, right? We'll just discuss this question 2. What is the question? Find the area of the region bounded by y squared is equal to 9x. Y squared is equal to 9x, and the two ordinates, x is equal to 2, x is equal to 4, and x-axis. For this we need to draw the graph first. Okay, and you know that y squared is equal to 9x is a parabola, so just draw the parabola first. Right? So you can draw only in the first quadrant because it's given in the first quadrant. Anyway, if you draw like this, it's okay. And next, we'll just draw the ordinate x is equal to 2. So this is x equal to 2 and say this is x is equal to 4. So clearly we need to find the area of these portions. We need to find the area of these portions. So we'll just use the theory that we have just discussed. Okay. So if you just calculate required area is equal to 2 to 4. That is a to b y dx. Right? Here this is the function. That is y equal to fx. Exactly the first theory. So 2 to 4 y dx. Now what is the value of y? You need to replace y. Okay. This is 2 to 4 y value. So y is equal to under root 9x dx. Okay. Under root 9x dx. We need to only calculate. So to remember one thing, that to solve questions from this particular concept, okay, you should have a practice on different graphs. And now so we can take 3 out. So it will be 2 to 4 x to the power half dx. So we just need to integrate. So you can integrate this. So this is equal to 3. This is x to the power 3 by 2. Right? 3 by 2. Fine. And this is 2 to 4. So just cancel this. If you cancel this, this is okay. So 2. The 2 will be left out. Right? So now if you substitute, this will be 4 to the power 3 by 2 minus, okay, minus 2 to the power 3 by 2. Right? We need to only simplify. So 3 and x to the power half, so x to the power 3 by 2 by 3 by 2. So it will be 3 will cancel out. So just 2 will go up. This is 2. Then you need to substitute the value 4 to the power 3 by 2 minus 2 to the power 3 by 2. So what is 4 to the power 2? 4 to the power 3 by 2. So 2 to its 4 can be written as 2 to the power 2. 2 will cancel out. 2 cube, that is 8 minus 2 to the power 3 by 2, right? So it will be 2 to the power 3 by 2 means that is 2 root 2. Okay. So if we just multiply, okay, if we multiply it will be 16 minus 4 root 2. Okay. So this is the answer for these questions, and the steps are also easy and the graph is easy. Well, let's move to the next question. Okay, this is question number 4. Find the area of the region bounded by the ellipse. Okay, that you already have learned ellipse, parabola, hyperbola, that is conic sections in class 11, right? So that's the questions. If you have some knowledge about this particular ellipse, so solution of this questions will be very simple. Find the area of the region bounded by the ellipse x squared by 16 plus y squared by 9 equal to 1. Okay, first we'll draw the ellipse. So as you can see that, so it is this is an ellipse along x-axis. So let's draw the ellipse. And another one important property of this ellipse is this is symmetrical about the axis, that is x and y axis. And what's the question? Find the area of the region bounded by the ellipse. So the whole portions that is bounded by the ellipse you need to calculate. So if you need to calculate these portions, all the 4 portions which are lying in the 4 different quadrants, you need to calculate. Okay, and the good thing about this ellipse is it is symmetrical about the axis. So we need to calculate only one area and we'll multiply by 4. For that, say we'll just find the area of these portions. Okay, this is 0, 0, you know. So we need to know the coordinate of A and say we all, right, coordinate of B. Now what is coordinate of A, right? We know that this is the semi-major axis. So here, what is A here? So here A equal to 4, because x squared by 16 can be written as x squared by a squared. So here a equal to 4 and b is equal to 3. So based on that, you can write the coordinate. This is 4, 0, 5. This is 4, 0, and this is 0, 3. So we'll find the area of the ellipse. Okay, and we'll just first find the area in the first quadrant and multiply by 4. So it's just one line you can write, the required area 4. Okay, 4, this is 0 to, you have to integrate from 0 to 4, 0 to 4 y dx. This is up to this one is the most important concept. The next is only integrations. Okay, so just need to integrate now. Okay, so just integrate the remaining portions here. Fine. 4, right? 0 to 4. Now y dx. So we need to calculate the value of y. So x squared by 16 plus y squared by 9 equal to 1. Fine. So from this, if we calculate y squared by 9 equal to 1 minus x squared by 16. Fine. And if we simplify this, what do we get after simplifications? If we simplify, so it will be y squared is equal to 9 by 16. Okay, 16 minus x squared. This is the value of y squared. So you need to write the value of y. Now what is the value of y? So y value will be 3 by 4. Right? Y value actually should be plus minus 3 by 4. But since we will be considering y, right? We are calculating the area in the first quadrant. So therefore just consider only the positive value. So y is equal to 3 by 4 under root, right? 4 squared. You can just write in this way. 4 square minus x square. You can write like that. So just replace the value of y. Y is 3 by 4, right? So under root 4 squared minus x squared dx, right? So and now we just can simplify this. You can just take 3 by 4 out. 4 cancel out. 3. So it's 0 to 4. So under root 4 squared minus x squared dx. We don't need this portion now. We'll just integrate. Okay, we'll integrate. Most important, as you have seen, that in most of the applications of integral, you are going to use this formula, that is under root a square minus x square, the most important formula. So just use this formula, 3. So yes, this is x under root a square minus x square, that is 16 minus x square, okay, by 2, fine, that is plus what? For the next step, plus a square by 2, that is 4 squared by 2, okay, a square by 2 is 4 squared by 2, sine inverse x by a means 4. Now you need to substitute 0 to 4. It's okay now. This under root a square minus x square formula, x root a square minus x square by 2 plus a square by 2 sine inverse x by 4. Now we are going to substitute this 3. In case if I substitute 4, so this term, that is 16 minus 4 squared, will become 0. So this first term we are going to get 0. First, then this is 4 squared by 2, so 16 by 2, it's 8. Then sine inverse 4 by 4. Sine inverse 4 by 4 means sine inverse 1. Sine inverse 1 you can directly write, it's pi by 2, right? It's pi by 2. Then minus. If I substitute 0, this part will be 0, this portion. And if I substitute 0, this is sine inverse 0 is 0. So you are going to get only 0. What is left out? Left out is, you can cancel this. This is 4. And if you just multiply, 4 is a 12 pi. So this is your answer. As you have seen, that answer is as simple as this. Okay. If you have the idea on the conic sections, if you remember the formula, right? So solutions like this questions is really very simple. Okay. And next this question, this particular exercise has got some varieties of questions. I have taken a question from ellipse. There is one more question on ellipse along y-axis. You are going to solve this question by yourself. Then just coming to question number 6. Find the area of the region in the first quadrant enclosed by x-axis line x is equal to root 3y and the circle. So this is a question from circle and line. Combination of a line and a circle. So just going to solve these questions. Okay. X-axis, line x equal to root 3y and the circle. Okay. First of all, let us draw the graph. Okay, we'll just take a circle. Okay. And then And as you have seen, okay, as you can see that the circle, this one, the center of the circle lying at the origin. Okay, and next, we're just going to draw this line x equal to root 3y. So if you draw this line x equal to root 3y, okay, so just can draw the line like this. So you know that it is, yes, this is a line x equal to root 3y. So this is root 3y line, and this is x square plus y square equal to 4. That means the radius of the circle is 2. Okay, and what I'm going to do is, this is a point of intersection. We'll just draw from there. We'll draw a line from this point of intersection. We'll draw a line. Right. So let's see the questions. That find the area of the region in the first quadrant. Here we need to calculate here. Okay, and enclosed by x-axis. This axis lines this line and by the circle. So which portion we are going to be talking about? We're just going to calculate these portions and plus this portion, these two portions, right? And one portion is this portion plus these two portions, these two shaded area. You are not going to calculate this. Most important, the first important thing, right? Okay, steps to be done is the point of intersection. This point of intersection you need to calculate. Remember this line is to be drawn from this line, right? This point. Okay, we need to say, assuming that this point is A, right? This point is A. So we're going to calculate the point of intersection. To calculate the point of intersection, you need to solve these two equations. That is, so here x is equal to root 3y, x equal to root 3y, and x squared plus y squared equal to 4. So we are going to solve this. Now, in place of x, if I substitute root 3y, so it will be 3y squared. Fine, I'm just eliminating x from the first equation, that is x equal to root 3y. So this is x squared means 3y squared. Okay, 3y squared plus y squared is equal to 4. Then this is 4y squared is equal to 4. So this gives us y squared is equal to, right, 1. This implies y is equal to plus minus 1. So just consider, in this case we'll consider y equal to 1. We'll consider y equal to 1 because at this point we are going to calculate the value of a, the coordinate of a, so which is lying in the first quadrant. So y value should be plus, that is y equal to 1. So in case if you consider y equal to 1, okay, we can move to the next slide. If y is equal to 1, right, if y is equal to 1, let us see what is the value of x, right, x value. We can see that the equation of, if you consider y is equal to 1, then x value will be root 3. Okay, so x value will be, that is root 3. Therefore, if I just redraw the figure, fine, okay, and I just draw this. So this is a line, and okay, and this point we are talking about a, right? A is equal to root 3. Fine, root 3 and y is 1. So this is, right, this is the point, root 3, 1. And what is this point B? What is the coordinate of B? B, 2, 0. 2, 0. Fine. So the coordinate of A is root 3, 1, and B is, the coordinate of B is 2, 0, because the circle is x squared plus y squared equal to 2. This is the given circle. The radius of the circle is x squared plus y squared is equal to 4. It's given as 4. Okay, it's given as 4. This is the circle, 4. So radius is 2. So radius is 2. So therefore, how to integrate now? So just required area. Required area. First we'll calculate these portions. That is, we'll just start from 0, 0 to the x coordinate of A. What is the x coordinate of A? It's root 3. So 0 to root 3 y dx plus, then we'll need to calculate the area of these portions. So how to calculate the area of this portion? We'll start from integrating from root 3 to this point. So x coordinate of A and x coordinate of B. So we'll start from root 3 to 2 y dx. Right? So now, in case if you write these expressions like that, don't forget to write the lower suffix. 0 to root 3 y dx means you are calculating this area, these portions. So if I use a different color, it will be more clear for you. Yes, these portions. And this portion is bounded by this line, bounded by this line. Okay, the first integral is bounded by line. So you just write YL, lower suffix. Then root 3 to 2, right? Root 3 to 2. This portion is not bounded by this line. This portion is bounded by this curve. Curve means the circle. So just can write YC. Fine. So it's 0 to root 3 YL dx, root 3 to 2 YC dx. So in case if you just write like this, you are not going to make a mistake in exam. So next step is this. 0 to root 3 y line. That means we are going to replace the value of y, okay, from the equation of the line. So what is the equation y value? That is x equal to root 3 y. So y is equal to x by root 3. So this will be x by root 3. Fine. X by root 3. Then next, okay, dx. Fine. And plus root 3 to 2. That is y circle. Y circle means y value. Y value is equal to under root 4 minus x squared. Under root 4 minus x squared. Yes. So 0 to root 3 x by root 3 dx, and then plus root 3 to 2 under root 4 minus x squared dx. Okay, and you can, this particular area, you can calculate area with the help of this simple formula half into base into height also. Okay, if you calculate this area by half into base into height, without this particular integration, you can quickly answer these questions. Okay, this is half into this length. This length is already given, root 3, right? This is root 3, and the height is equal to 1. That means this answer should be, this integral should be root 3 by, this particular integral should be root 3 by 2. You can calculate using the half into base into height formula, or you can use integration also. Next step is, so as already you have started with the integrations, we'll just continue with this. 1 by root 3, fine, this is x dx, means x squared by 2. Okay, x squared by 2, and this is 0 to root 3. Fine. Next, again this is a common formula. So this is x 4 minus x squared by 2, 4, okay, plus a squared by 2. What is a squared? That is, a means 2, a squared, that is 4 by 2 sine inverse x by a, that is x by 2. You can graph this now. Fine, we just need to concentrate only this, that is the integrations, the limits is root 3 to 2. So we'll just calculate the value, only our calculation is left. This is 1 by root 3, and if you substitute root 3, right, so it will be 3 by 2, and if you substitute 0, it will be 0. So we'll get 1 by root 3 into 3 by 2. Plus, if you come to these integrations, if you substitute 2 there, right, so this portion, if you substitute 2, this first integration will be, first term will be equal to 0. Then plus, you are going to substitute 2 there. So if you substitute 2, if you cancel 4 by 2, it's 2 into, if you substitute 2, so sine inverse 2 by 2 is sine inverse 1, that is 5 by 2. Right, now let's substitute the lower limit. If you substitute lower limit, right, this is minus, so it will be root 3. And if you substitute root 3 there, root 3 squared is 3. 4 minus 3 is 1. Right? So it will be only 1 by 2. Fine. Right? If you substitute root 3. Then it is coming to this. Okay? Plus 4 by 2 means it's 2. And sine inverse if you substitute root 3, it's root 3 by 2. Done. Okay. So let's just continue. If you cancel 3 by root 3, okay, it will be root 3 by 2, okay, plus, and I can remove the bracket now. So okay, this is 2 cancel out, it will be pi, fine. Okay, this is minus root 3 by 2. Okay, it's minus root 3 by 2 plus. So if you multiply by plus sign, it will be minus, right? 2 into sine inverse root 3 by 2. It's pi by 3. Okay, pi by 3. So it will get cancelled out. It's pi minus 2 pi by 3. Okay, pi minus 2 pi by 3. It gives you pi by 3. Right? So this is the answer for these questions. And you can see, like, okay, that if you can draw the figure properly, and if you have practice on the integrations, like, okay, application of integration will definitely not be a problem. Okay.